Hello and welcome back. As today, I am going to introduce you to trigonometric functions. But first of all, what are trigonometric functions? Trigonometric functions are derived from triangles, with their most simple versions derived from right triangles. However, their applications are broad in reach and are used in complex fields like radio transmission and subatomic physics. Let's start with the basics. There are 6 basic functions that need to be memorized: sin, cos, tan, and their inverse, shown in the table below. We will also be using the 3 parts of the right angle: the hypotenuse, which is the long side, the adjacent, which is the line next to the angle, and the opposite, which, as mentioned, is the line opposite to the mentioned angle. First is the sine function. In its most basic form, it is the length ratio of the opposite to that of the hypotenuse. Here is what it would look like in an easy problem. Could be given these informations about a particular right triangle and be asked to find the length of said line. Here's how you would do it. By plugging the 37-degree angle into the sine function and then multiplying it by the length of the hypotenuse, which in this case is 19 meters. We get a final answer of around 11.43 meters. Another important take from this seemingly simple problem is that exercises are often not to scale, so proper calculations are often necessary. This is the cos function, which represents the length ratio of the adjacent on the hypotenuse. Here, we can see a visual representation of the adjacent being 85% of the length of the hypotenuse. Here is another problem, but this time involving cos. Again, see the same triangle as before, but now let's find the adjacent angle. Unlike the other problem, this time we use the cos function and multiply it by the hypotenuse. Using the same steps as before, we find that the length of the side adjacent to the angle is close to 15.17 meters. Last but not least is the tan function, length ratio of the opposite on the adjacent. In this visual representation, we can see how many opposites fit in the adjacent side's length. Again, you know the drill. Here's one last problem. Following problem, we will use the tan function to find the opposite by plugging the angle into the tan function and multiplying it by the adjacent length. You can also notice that I used the same angle as the previous problem, as well as the same adjacent length. Therefore, the opposite should have the same length, considering the triangle is the same. And such is the answer we get, with the opposite being 11.43 meters, which, as you recall, is the same answer as the first problem. Now, let's see a slightly more complicated problem. In this scenario, you may be given an object moving in a certain direction, and be asked how much it moved forward and how much it moved upwards. That's tricky, but here's how you do it. Firstly, for the distance forward, you may be able to see that the line at the bottom of the triangle, representing movement forward, is kinda like the adjacent angle of a right triangle, since it is next to the angle and would make a right angle if its end was connected to the arrow's end to form a right angle. Therefore, we can calculate its displacement by simply multiplying the angle's cosine by the length of the hypotenuse. Secondly, for the distance moved upwards, you may want to visualize another line, which I have put in dotted lines in the problem, that is parallel and therefore the same length. Now, this length, as you may have already recognized, is the opposite of the aforementioned angle. Therefore, by multiplying the sine of the angle by the length of the total displacement of the object, you can get value in meter for the upward displacement. This is a problem which you may want to save for later, as it is a textbook example of vector decomposition. This second problem should be rather straightforward. It is the case of little Jimmy, who, one day at recess with his friends, got asked to find the height of the biggest tree in the playground. After getting measure tape and an angle reporter, he figured out that, at a distance of 52 meters, the angle from the top of the tree is 13 degrees, as shown in this problem. Now feel free to pause the video and solve the problem by yourself. There are many ways of solving this problem, all of which arrive at the same answer. But in this instance, it is most easy to use the tan function, since we don't actually need to find the value of the hypotenuse. All we have to do is plug the angle into the tan function and multiply this ratio by the distance that Jimmy has gathered. And there we have it, 12 meters high. Now, this last one is the trickiest and will require you to use multiple steps, but it is possible. So here's the outline. Two lasers are shot at a house. The first one, directed directly at the top, has an angle of 22 degrees. The second one, directed 2 meters below, has an angle of 13 degrees. Using these two calculations, you want to find the total height of the house, which is represented as the dotted red line in the problem. Since this problem is hard, I would suggest you pause the video right here to try it yourself, and then come back to see the answer later. This solution is found using two main steps. The first one is to find how many brown lines fit into the big red line, and then use it to find the length of the hypotenuse. So first, we find the variable hr, the red line's height, to be 0.3746 times the length of the hypotenuse, which we haven't found yet. Then, we find the height of the brown line in terms of the length of the hypotenuse, by subtracting the rest of the red line by the total of the red line, showing us that the height of the brown line to be 0.1506 times the length of the hypotenuse. However, we already know the height of the brown line, which we plug in our equation and then solve for L. That turns out to be 13.28 meters. That is the length of the great line of 22 degrees. The second part is using this length we just found and plugging it in our first equations we made, where the total height is 0.3746 times the length. The end is easy. Just do the calculations and you find that the total height to be 4.97 meters. Afterwards, just add the final answer for conformity and bam, you are done. Thank you for watching this video. If you appreciated it, don't forget to share, like, and subscribe. See you next week.